Okay guys, so I have this new tablet. I'll see if this will help. The question that you're asked to solve has a block on a ramp. And so I went ahead and first of all drew my free body diagram. I have the normal force perpendicular to the ramp, and I have the weight straight down. Anytime you have these forces acting on an angle, what we talk about is we say we tilt the axis, which means that what I'm going to do is take the whole xy axis in the system and make the x-axis on the ramp and the y-axis perpendicular to the ramp. The advantage to that is that now all of the acceleration down the ramp is one-dimensional. So when we do the sum of the forces equals the mass times acceleration, we will only have acceleration in the x direction. So now I'm going to come back to my picture, and I just want to break my weight vector, sorry, still learning this, into components. So here's the x, it's parallel to the ramp, and here's the y, perpendicular. Now you could convince yourself with similar triangles, but this angle down here is the same as theta. Here's the right angle, here's the right angle. I honestly think it's easier to figure out which leg is which by just making sure when you draw your ramp, one leg is definitely shorter than the other. So this is what I'm going to call W sub y, the y component of the weight, and this is what I'm going to call W sub x, the x component of the weight. Okay, so down here I'm going to write the sum of the forces in the x direction equals the mass times the acceleration in the x direction. And the sum of the forces in the y direction equals mass times acceleration in the y direction. So this is kind of like the habit. This is what I do every single time. I look at my picture and I look at what vectors are on the x-axis. In this case, it's just wx. So I write wx equals max. And in the y direction, I'm going to say n, because it's pointing up, I make it positive, minus w sub y, it's pointing down, that's why it's negative, equals 0. The reason why it's 0 is because we've tilted our axis. The acceleration in the y direction is 0. The block is not floating or sinking. So the normal force in this case equals w sub y. Alright, over here for wx. So wx stands for the x component of weight. It's this leg here that's opposite theta. So I'm going to rewrite that as mg sine theta, in this case theta is 15 degrees, equals ma. So people often think they need the mass of the block, but the truth is most of the time that mass is going to cancel. So the acceleration down the ramp is going to be 9.8 times the sine of 15. Okay, so they're asking for the time. The block starts from rest. So V initial is 0, D is 20, A is 9.8 sine 15, which is some number, and we're solving for T. So, let's see here. I'm going to choose the equation without V in it. So D equals, oops, sorry guys, V naught T plus 1/2 AT squared. 20 equals, well, 0 times T is just 0. So then I get 1/2 times 9.8 sine 15 times T squared. And now you're just doing simple algebra to solve. All right, hope that helps.